Alright then, we're looking at the Year 12 textbook exercise 8A question 5, which is all about logarithms and exponentials. And we're told that I have some function where y is equal to e to the 1.5x. I tend to write these as fractions, so I prefer e to the 3/2x. So of course the analysis is exactly the same regardless. And I'm asked to find the gradient at 2 points. I want the gradient of the curve in part A. It's at x equals negative 2.1, and in part B it's when y equals 12. And by looking at these we can look at a clever little piece of work we can do when we ask for what the y value is. So we start straightforwardly. In both cases we're going to have to differentiate to get the gradient, of course, and so I say dy by dx of an exponential function is going to be the that number, so that's 3/2 times e to the 3/2x, and that's from the laws of exponents and how we find the gradients. So that's going to be the same in both cases. In part A then, I'm told that x is equal to negative 2.1, and simply the gradient then is 3/2 using this formula over here, e to the power 3/2 times negative 2.1. And all we do is put that into a calculator and we're sorted. So I'd say that's 3/2 times e to the power of 3/2 is 1.5 times negative 2.1. And I get an answer which is 0.0643. 0.0643 to 3 significant figures. It's a perfectly good answer for part A. For part B, though, it's actually it's a lot simpler, but we can complicate it by accident. Let me do if we were to follow exactly the same reasoning here, and say that I'm told that y is 12, but I know that my gradient is given as 3/2 e to the 3/2x. So I'm thinking to myself, I need to know a value of x. So I use my y is 12. I know that y is e to the 1.5x. So I can calculate what my x is given I know my y. So I change the equation to be 12 is e to the 1.5x to find the value of x when y is 12. I take natural logarithms of both sides. Log of 12 is 1.5 times x. So x therefore becomes, let's call that again 3/2x, it's easier to manipulate. X then I times by 2, divide by 3, and get 2/3 log of 12. And that's a good intermediate step. Now I've got my x's 2/3 log of 12. I can put that back into this formula here, which I calculated earlier for the gradient, and say that my gradient then is 3/2 e to the power of 3/2 times 2/3 times log of 12. Well, that 3/2, 2/3 cancel completely, and e to the power log 12 is simply 12. 3/2 times 12, which is 1.5 times 12, which is what, 18. And there's my answer. Now this looks very simple at the bottom. It's just a fraction times an integer. That's hardly challenging. So why do we have to go through all these steps with some weird logs and some fractions kicking about as well? Well, the truth is we didn't. If we think about it a second, we say the gradient using this exactly the same as this formula is, we're happy that the gradient is 3/2 times e to the 3/2x. And we're happy also that y is simply e to the power 3/2x. Well, you can see therefore that I can take this e to the power 3/2x and just call it y. So my gradient is in fact 3/2 times the y value at any point. And so when I'm given my y value, as in this case I'm given y is 12, I can calculate it directly by simply putting 12 in there, and I get 18 in basically 2 lines of working rather than several.